Guys, welcome back again. Now we're gonna do for the 100 Days of DevOps series. So today is day 60. We finished day 59 yesterday. So now it's time for day 60. So let me check it out at lab title. So recently I tried to complete the challenge, but I failed it. Yeah, honestly saying I failed. Here you will see the red sign right here. So let's try together right now. So here the lab title is Persistent Volumes in Kubernetes, right? So we have to create persistent volume to keep the story data permanently, because generally you can simply understand like this. If we delete Kubernetes pods, so they are related data keeping within it, they will also be removed, right? So that's why we need to create the persistent volumes. So okay, let me redo it. Oh, what's wrong? Okay, great. So let me go to appdrawer.com. So I have prepared an architecture diagram for this lab right here. So now we are on the Kubernetes cluster. So within the Kubernetes cluster, we have to create resources, and we have to manage, we have to attach each other to work together, So yeah, generally we have to configure many things, to be running, right? Okay. So I will explain this diagram later when we read the given instruction. So okay, let me copy first this given instruction. Okay, great. So here, so the notorious DevOps team is working on a Kubernetes template to deploy a web application on the cluster. So there are some requirements to create and use persistent volumes. So the key point is to store the application code. The reason why they use persistent volume is to store the application code, right? And then the template needs to be designed accordingly. So to do this process, so we have to modify the template. We had to design a template again, according to the requirements, right? So we had to find some more details below right here. So we have 4 requirements. So the first thing is we have to create persistent volume. So within this Kubernetes cluster, so we're gonna create this persistent volume. So persistent volume name is here pv-datacenter, and then we're gonna have to configure the specification. Your story class name is manual, and capacity amount is 4 GI, that means 4 GB. And we had to set access mode. Access mode is ReadWriteOnce, and volume type is hostPath, and we had to set path to this correct directory. So this already created, so we don't need to create it, and we don't need to worry about it. So okay, so let me create the first thing, that is persistent volume. Okay, let me find the Google. So I will copy the whole sentence. You can copy like that, and I will run this. So here we will use the YAML code. So that's why we need to create a YAML file first. So I gave the file name is pv in short form. So I will create with the vein editor. I will get the pv ending with the YAML extension YAML, or not, it's a YAML. Alright, great. So within the file, I will copy all of these codes and I will paste right there. But we had to check it again, not to get it wrong. Alright, so here persistent volume kind is not pod, not deployment, and no container. It is persistent volume, and metadata is pv-datacenter. That's correct. Here specification, story class name in manual. That's also correct. Capacity 4 GB, and access mode is ReadWriteOnce. That's also correct. Here like this. Here is a volume mount pad is /mnt/finest, right? So now everything looks perfect. So let me escape that. Escape and save it, column w2, And then this time we had to apply this YAML file to create their persistent volume. Apply -f and then pv.1eml. Sorry. Great. So let me run these comments. So you can get pv. So you will see this pv-datacenter persistent volume here. So state that is available, right? Great. So now it is time to create persistent volume claim. So what does it mean by persistent volume claim? So persistent volume claim is similar, we kind of like the instruction. So it will request to this persistent volume, give me 2 GB according to the requirements, So this persistent volume has to bind with this persistent volume claim to connect together and work together, right? So here, now we will copy this whole sentence. So persistent volume claim name is pvc-datacenter, and here specifications are storage class name is manual, request amount is 3 GB, and access mode is ReadWriteOnce. That is the same. So let me find a new tab. So here also again, I have to create a YAML file again. So this time I will get the pvc.yaml, YAML YAML. So within the file, I will copy all of these codes. Okay, great. So kind is this time persistent volume claim, right? So metadata is correct, PVC, not PVC. So storage class name manual, access mode is ReadWriteOnce. So request storage amount is 3 GB, right? So great. So escape, save, colon, W2, and apply it. Okay, apply -f pvc.yaml. That's great. So that time we'll get the key get pvc. So here is capacity 4 GB, and here's data is bound, right? We had to bound, right? We had to bound persistent volume with that persistent volume claim. All right, so now it is time to create a pod. I always run to pronounce this name.
Pod.
Yeah, pods. The pod name is pod-datacenter. So, and then we had to mount the persistent volume you created with the claim name. So here is the PVC name. So, but we shouldn't forget, to mount at a specific directory. So specific directory is here, document root directory of the web server. So here. So we create the pod, and then within the pod we have the container. At least we should have one container. So that container is leading to this volume mount directory to mount the volume, right? So we have to get a specific mount path right there. So here is we had to get the document root mount path. So container name has to be container-datacenter, and at the same time we have to use image name is HTTPD, not Nginx, with the latest tag. All right. So remember to mention the tag with this format. Okay, we had to use this format. So here the same applies here again. I will use the same method to get the related comment. Okay. So let me create again with the vein editor. This time I will get pod.yaml. So within the file, let me copy this code. So here we need to consider carefully. One more thing is that here, this pod is connecting with this NodePort service. So this NodePort service, we have to create it later. So NodePort service, right? So when we create a port, we need to give the app name as a label. So we need to give the correct app name because we had to join NodePort service and port together, right? So if the app names are misaligned, so we get into trouble that will not work properly, right? So that's why. So you have to carefully copy this. So here, but we copy successfully. So kind is port, correct? Port name is pod-datacenter, correct? but you know, we have to get the app name. So I will get the labels, and app name. So I will get app name that I like to get. So I will get the web-datacenter, CNTR center. So because we had to apply this app name when we create the NodePort service, so I will get this name. We need to remember this. And then container name is correct, and image name is latest. And volume mount path is this. This is a document root directory mount path, mainly for HTTP image. But if we use Nginx image, it will be different here. Mount path is different, not this one. So here also volume mount path name is, you can get any name that you like to get. And here is the PVC name that we get right here. PVC names right here. So okay, here you can find volume mount path for HTTPD and Nginx and Kubernetes port. So here, this is for web root. This is for the Apache HTTPD service. But if you use Nginx, you have to use this correct mount path. But now we use this because now we use HTTPD image, HTTPD service right here. That's why I use this. Okay, so now everything is correct. So I will escape it, save it. Okay, great. So let me get key get port. We don't have that, so key get port. Oh no, I had to apply that. Sorry, if applying -f port YAML. Okay, great. So key get. Let me get port. So here, it's not ready yet. It's still creating. So let me run that again. Okay, now it is creating. Still is running. Great. So this is the final step we have to create. So this time we have to create this NodePort service to connect with this port, a Kubernetes port, to work together. So this NodePort service will receive the user request from the browser. So here the user send a request through the browser using HTTP method or HTTPS method using a specific port number. Here they will use 3008 to connect with this NodePort service. But if you like to get that directly access into this port, so you need to get the port IP address and specific port number that is listed on. Okay, so now we create a NodePort service. So I will run this, I will copy it again, I will find a new tab. So here I will create a new file again using Vim editor. I will get this time for service, so I will get svc.yaml. You can get any name you like to get, that's fine, totally fine. Okay, so now I will copy this. So here I will copy this whole code. Alright, so but here we need to modify it again. Kind is service. This time we have to get a service because it is for NodePort. So metadata NodePort name is web-datacenter and type is NodePort. So here very important, here select the name. App name is ensure this match the labels on your port. So on the port we get that app name is web-datacenter. Right? So we need to get the correct name right here. This is very important. So here protocol type is TCP. So this port is for this NodePort service. Port 8 is for this NodePort service. But this target port is for this Kubernetes port service. This port service. But this NodePort is listing on this number. NodePort number is 3008. So now everything's correct, right? So let me escape that, escape, save it, and then I had to apply -F. Oh, not 3 times. Okay, great. So this time I will get the file name. Okay, great. So we successfully created a NodePort service. So now it is time to request from this jump host server to this Kubernetes port to get that web page, right? So let me get the IP address of this port. So to get the IP address, I can run this get endpoint. Oh, sorry, that's endpoints. So here, this is web-datacenter. This is the app name. Web-datacenter is app name within this port. Here, this port, right? So okay, so here that one is listing on port 80. So this time we can run the CUI code HTTP. We http that, and then // and I will copy this IP address. So here we get this HTTP page. Oh, sorry, HTML page, right? Let me find in the browser. Yeah, that's it. So here we don't get there. We cannot get send a request to there. Anyway, so we get this HTML page. Finally, we are able to send the request to the Kubernetes port. Okay, great. So now let me check it out. Click confirm. Yeah, so that's it. So if I can do it, you can also do it too. So here, thanks for watching. I will catch you in the next coming video again.